Hi, this is Tom, and in this video we are going to learn about our last piece, of linear regression, and that is this. This is lesson 36, and we're going to talk about the coefficient of determination. All right, here we go. This is the same data set that we've now used in the last few videos, and I have the data recorded down here on the left. The actual data value is 1, 1, and for example, the predicted value from our linear regression model of 1, 7 sixths. So we're going to go through a number of steps here. Let's begin with this. We're going to find the mean. Find the mean of y and y prime. So we're going to calculate both of these. So here we go. So if we want the mean of the y's, well, we would take our 1, we have a 2, and another 2. There's 3 data values, or 3 y values. We'd add that up and we'd come up with 5 thirds. And then let's try finding, now here's y prime, let's find the mean of that. Well, now this looks harder. I have some fractions, so let's take 7 sixths plus 5 thirds plus 13 sixths. I'll divide that by 3. And I'm going to need a common denominator for this problem. So let's get that. So let's see, this is going to give me, looks like I'm going to need 6. So I'm going to have, that's going to be 7 over 6 plus 10 over 6 plus 13 over 6. All of that is over 3. And let's see, 7 plus 10 plus 13, that's 30, divided by 6, that's 5. So I have 5 thirds. And notice this, the point of this is that whenever you're finding the mean, you can find either the mean of the y's or you can find the mean of the y primes because they're always going to be the same. All right, so in general, we just normally would find the mean of the y's. Now I'm going to graph this. So we're going to graph the mean of our y's. So we're going to graph the mean of y equals 5 thirds. And we'll do this in a different color. We'll put this in yellow. So 5 thirds is right here. So I'm going to just draw my line. And that is y bar, or the mean of y's, is 5 thirds. And it's from here that we can begin taking a closer look at our picture. And here's what we need to see. We need another color for this. We'll use pink. Look at this. So the gray are the original data, and the blue are the data that the predicted values that resulted from linear regression. So we're going to call the distance, here between our mean and the actual data value. So we're going to call this distance right here, that is what we're going to call our deviation. So this is going to be this distance here. We're going to call it t. Oops, let me erase that. We're going to call that t1. That's my total variation on the first point. So we're going to do this. So where t is total deviation. So for example, t1 would be the total deviation of 0.1. And if we look at 0.2, again, we go from the mean all the way up to our data value. Oops, that turned out kind of strange. So let's just go on. It's this right here. That would be t2, that distance. And our last one is this one. It's actually a little smaller. This is t3. Okay. So those are our total variations, but total deviations, but we have a couple more. Let's put those in orange. So the next thing that we have is what's called the explained deviation, and that comes from, if we go from the y to our actual predicted value, this one, we're going to call this d, and d is explained. And I'll explain explained deviation because it is part of our linear regression model. Linear regression model. Okay, so those we're calling D. So this first one here, this would be D1. And then, oh, look at this second point. Notice that it does the D2 here. So that little point there. And in this case, there is no explained deviation there. It lands right on the mean. So we just say 0. And in the last one, the explained deviation would be from the mean up to this point here. So that would be D3. Now, unfortunately, our model isn't perfect. Our model is not perfect. And so, in order to account for that, we have one more piece, and this is E. And E is the error. It's the part, the part the model does not cover, or does model part the model does not account for. Okay, and so the error here we'll do in this color here. So this between the T1 and the D1 that's our error there. And then our error in our second point is the distance from the y prime to, that's our second error, is this distance. And our third error is this distance. Now, we're going to take a moment here, and we're actually going to calculate our various errors. So let's try this. So we're going to calculate the t's here. We're going to do this for all of these. So let me undo that. And our t's are in the pink. So let's do pink here. So this is our total variance. So our total variance is actually what you would expect as if you were calculating standard deviation. And so that is very simply the data minus the mean, and you get some number. In this case, we're going to come up with 1 minus, it's minus 2/3, and then a 2 minus 5/3, and that's going to give us 1/3. And finally, 2 minus 5/3 for another 1/3. Okay, so that is the t's. Now let's do our next one, where the d's, and those are in orange. So the d's are the distance from the predicted value to the mean. So for example, we have 7/6 minus 5/3. And that's going to be 7 minus 10, so that's going to be negative 3/6, which is minus 1/2. And our next one is going to be 5/3. And the mean is 5/3. Oh, look at that. That's 0. I can calculate that. And then our last one is going to be 13/6 minus 5/3. Well, that's going to be, remember I need a common denominator, so that's going to be a 13 minus a 10. So that's going to be 3/6. Oh, that's 1 positive 1/2. All right, and the last little bit left to calculate here. I'm going to carry my line here over a bit more. Didn't do a very good job on that one. Let's just undo that line and let's put a good line on there. Guess it doesn't want to do a good line. All right, so our final one was the error. So this was our e's, and the e's we did in the light green. So let's do it. Calculate our errors. So the errors are the distance between the actual data minus the predicted value. So our actual was 1 and our predicted value was 7/6. So that's going to give us a value of minus a sixth. And then the next one, our actual data was 2 and our predicted was 5/3. So that is going to give us 1/3. And then the last one, our actual was 2, but we predicted 13/6, and so that's going to be a minus 1/6. So let's do this. Let's go back and let's add up our columns. Add up our columns. So notice if I add up my pinks, let's add the pink columns. If I have minus 2/3 plus a 1/3 plus a 1/3, well, that's just 0. So we're going to add all these up. That's what we're doing right now. We're just adding our columns. So this is the sum. Okay, and then let's add up our explained distances. Well, I have minus a half plus a 0 plus a half. That's also a 0. And if we add up our errors, I have minus a sixth minus another sixth. Well, that's minus 2/6, which is minus 1/3, but I have plus a third. And look at that. The sum of all of these deviations or residuals is 0. So in the next video, we're going to see how we correct for the fact that the sum of all of these residuals and deviations is 0. See you in the next video. Thanks for watching.